Hello and welcome to a new project on visualizing anomalies in the dataset by Security Ninja. So in this project, I'll be showing you how to visualize data using different Python visualization libraries such as Matplotlib and Seaborn. We will also look at how to extract, clean and transform and load the data from different files into data frames. So let me give you the introduction. So in this project, as I told earlier, we'll learn how to visualize the anomalies in the dataset, and we'll also look at how to extract, clean, transform, and load the data from different files into data frames. Data frames are special data structures used specifically for storing data and helps us to visualize it. You will also learn how to use Pandas library using the Matplotlib and Seaborn to create stunning dashboards. You will also learn how to plot different types of plots, charts, graphs, and also customize them as per your requirements. While learning data science, it's always best thing to solve case studies also in order to grasp the concepts more effectively. So what are the requirements? So you must have basic knowledge of how to use integrated programming environment, that is IDE. Then you should have a basic knowledge of Python programming language. So what is the target audience of this project? Anyone who is willing to learn the cutting edge technologies such as data science, anyone who is interested in learning how to leverage different libraries for data visualization, anyone want to learn how to visualize anomalies in the dataset. So if I give you project outline, in the first session, we'll learn how to set up project environment. Then in the second session, we'll learn different Matplotlib library plots and charts, how to draw them. In the session 3, I will show you how to visualize anomalies in the dataset using Matplotlib library. In the fourth session, we'll look at how to visualize anomalies using Seaborn library. And in the last session, we'll be learning about a case study on classifying a personal income of a population using a model and to visualize the data trends provided by the model. So let's get started. Programming IDs we'll use is Anaconda Navigator. So this is a free and open source distribution of Python programming language. So it's just search for Anaconda in the Google, and the first link, that is anaconda.com. Select that and it will load this page, and go down, otherwise select get started. In here, select install Anaconda individual edition. If you go down, just click on download and it will download the Anaconda package manager. So what this will do, this will help you manage your Python programming environment. So it's open source, it provides you Conda packages. So using these Conda packages, you can install different libraries, and also you can manage environments also. So these are virtual environments. It helps you to manage the dependencies of a project. And when you install that, the Anaconda Navigator will open like this. And in here, these different library, softwares will be displayed. You have to just install them. So install the notebook. This is Jupyter Notebook. We'll use this in the later session. The install Spider IDE. We'll use this for this session. And also install this Qtip console if you need that. And you have to see that applications on root, it is displayed here. And whenever you want to open any software, you can just click on launch and it will open that software, such as Spider IDE. So in today's video, you'll be learning about how to use Matplotlib library to plot different types of graphs. So we'll start with the simple plot. So I'll be using PyCharm IDE for this video series. So I'll open PyCharm IDE using Spotlight. Okay, so we'll create a new project. We'll give a project name as Matplotlib tutorial or tut, and we'll select project interpreter. So we'll select new environment using virtual N. You can also select pipin or conda, but I will select virtual N, and you can change the location if you want. The base interpreter is Python 3.6, and we'll click on create. It is creating the virtual environment for our project. Okay, we close the tip. You can see the project structure. We have the virtual environment directory. So in the bottom you can create on click on terminal tab and it will open the terminal. So here we'll type pip install matplotlib and press enter. So this will download the matplotlib library and it will install on our machine. So we'll wait till it get downloaded and installed. So while it is downloading, let me show you the matplotlib library and what is the use case of that. So we'll open a new window of Chrome. We'll type matplotlib. Let it load. So you can see the matplot library is a Python two-dimensional plotting library which produces quality figures in a variety of formats. So we can also use it with Python scripts and also with Jupyter Notebook. So it is derived from MATLAB. MATLAB is a multi-paradigm numerical computing environment. So we can go in examples. So here you can see the different graphs they are provided with, like stacked bar graph, horizontal graph. There are n number of graphs here. So each one has a demo code with that. So if you want, you can take a look at that. So these are scatter plots. We have bar graphs. I'll be using a simple plot to show you how to use matplotlib library. Let me click on particular. Okay, you can see the percentile as a horizontal bar chart. So they have given us the code also. So this code looks a little bit advanced. So we'll start from the basics, and as soon as we learn more about matplotlib, I'll be showing you how to use it to produce complex charts. So we can also create pie charts. So you can go through the gallery if you are interested in this. So it is still downloading. So it has downloaded and installed. So you can see it has installed different packages along with the matplotlib, like numpy 6. You can see the matplotlib in the end. So you can click on our project from project structure and new and click on Python file. So we'll give you the name as mat.1, which is matplotlib tutorial 1. So click enter, and as you can see, it has opened the file, and here we can import the package. So we'll use from matplotlib, we type import pyplot, and we can use alias as plt. So whenever you want to use pyplot, we will call as plt and the name of the function which you want to use. So now we have imported the pyplot package. So we'll import our data. So here we have a list. So I have put as 3 list. So I'll share the list with you, data.py file. So this contains the years. So I have copied this data from this particular website called Statistic Times. So in here you can see the China versus India population from 1950s to estimated year like 2100. So I have copied it from 1950s to 2030. So you can see it is from 1950s. So China has like 554 millions, and 2030 they have 1.4 billion, and India has 1.5 billion. So I copied that data and put it in the list in Python. So here contains 1950 to 2030. So I'll copy this year list into our mat tutorial 1 py in population China. So these floating point values are in billions. So keep in mind, I have not taken the whole number. I just scaled it down to the decimal point 2. So I'll use only 2 population China in here. So we'll plot this data using pyplot package. So we'll import the package using plt.plot. So this is a function. So inside this function, we'll pass the x-axis and y-axis values. So x-axis would be year, comma, y-axis would be population of China.
Okay, so after this, if you have to show it to the screen, so you will use plt.show function to display on the desktop. So when you run this, you will see this figure 1. So this is a simple plot. So in x-axis you can see the age, and in y-axis you can see the scale of the population. So you can use the pan function to pan around. You can use the magnify and see the exact details of the plot, and you can use these arrow keys to undo and redo. So if you want to go back, you can use undo, and if you want to get one step back, you can use redo. So I think this is about configuration of subplot. So also you can click on this save to save the file as PNG, save the plot as PNG format image, and you can also use home to bring it back to the original position. So we want to add x-axis and y-axis label, so we can do that using plt.x label. So this will display the x label values. So we pass a string as year, and for the y label we'll use plt.y label. In the parenthesis we'll give population in China in billions. Okay, so we'll make the year as y capital. Okay, we'll run now, and you can see the label is put up, and in x-axis we have year, in y-axis we have population. We can also add a title, but first I'll change the population. Okay, we can also add a title. So for that we'll use plt.title function. So inside this we can pass a string as population of China. So let me run again this program. You can see the title has come up as population of China. Now we'll import our another list, that is population of India. We'll copy and paste it in our Matplotlib tutorial 1 file. Okay, so now if you pass this population India list to the plot, it will not give an error. It will actually print that, but it will be not in a good format. So the better option would be to print it separately using plt.plot, pass year as the first argument, comma, population of India as second argument. Now we'll change the title as population of China versus India. Okay, now we'll run this. So you can see. So we cannot figure out which one is what, but according to our previous graph, you can see that blue is China and orange is India. So to know which one is what, we can use legend function. So for that we'll use plt.legend. So inside that we'll pass the values of the particular line as list. So the first string would be population of China. So we'll put at China, comma, next would be India. So put string as India and save, and now run. So you can see in the upper left corner we have blue for China and orange for India. So this is carried out using the function legend. So this is a little bit it can create problems in longer run if you are having more than 1 or 2 countries, like population of Brazil or population of Russia, for example. So if you have like 10, 15, then the order will be mismatched if you are working on a lot of countries. So for that, the better option would be using an attribute in the plot function. So I'll remove this, I'll copy this China. Okay. And now in the plot function we'll give an attribute as label equal to, we'll pass a string at China. And we'll pass India in the second plot as label equal to plot India. So what this will do, it will do the same thing as what legend was doing using the list. So instead of passing through legend, we are passing it through plot. Okay, so this is how you create a simple plot. So in the next video, I'll be showing you how to use different formatting strings and how to use different styles to make the graphs look more intuitive and more awesome.
Hello and welcome to another video. So in the last video we had seen how to plot a simple pie plot using Matplotlib library, and in this video I'll be showing you how to use different format strings to customize the plot, and also I'll be showing you how to use different styles provided by the Matplotlib library. We'll run our current plot. So you can see it is containing only the China and India population graph, and you can see the India is orange and China is blue color, and India is slowly increasing from 1950s to 2020, and at 2000 some two after 2020 it will intersect the China population. So we can use function provided by Matplotlib library called grid. So we can type plt.grid, and if we run a program now, we can see that our graph contains a grid now. So this is very much easier for us to understand at what time or at what period both the lines of the population will intersect each other. So it is around 2023, and you can also see it will be more than 1.4 billion. So at 2020, uh, China is ahead of India as per the data. So India is somewhere around 1 point below 1.4, and China is around 1.45 something billion. Okay, So now I'll go in Matplotlib website, and here you can see Matplotlib pyplot dot plot. So in here, if you go down, you can see the format string. So don't worry about the URL. I'll give this URL in the description of the video. So format string contains first marker and then line and then color. So so the other combination will also be working, but parsing of them might be ambiguous. That is, sometime it might be error prone. So it's better to use the given format string, that is marker, then the line, then the color. So so in the markers we can see we have point marker, etc., then pixel, circle. So the characters which are provided we can use for the particular markers. And also for line style we can see solid line style. This is the default, that is only one dash. And for dashed line style we have to provide two dashes. So by default solid line style is included by Matplotlib. So we'll go in our plot, and now we can add the format string in our plot function. So for that we'll put comma, and inside the comma we can use, in inverted comma we can give the format string. So for that we'll put first the line style, so that is dashed, and now we'll run. So here you can see in China's line, plotted line, it is given as dashed. So that is due to the format string which we have included. So let me close it. And for and now we'll go in the website, and you can see there are different line styles. So we can use dash and dot for dash dot line style. So for India we'll put one comma in the plot function, and inside that we'll type in two inverted commas, dash and dot. So India is dash dot. So we'll run now, and you can see the India is plotted in a dash dot line style format. And we have one more format, so that is colon, so in which dotted line style is included. So we'll make the China as uh, default format, that is solid line, and for India we'll make it as colon. So this will print the dotted line. So here you can see the China is now solid, and for India we have dotted. So now we will include the different colors. So for that we'll go in the website, and we'll go down, and here you can see the colors tab. So there are different keywords given. For black we can use K, for white we can use W, for red we can use R. So after the line style we'll type the keyword for the color. For China we'll give it as R, because as you know, as you all know, it contains red in the color of the flag. And for India we'll go with green, that is G keyword. So here you can see the red line is plotted for China, and for India it is green. Now we'll make it dashed for India, the line style, and for China we'll now include a marker. So for that we'll go and top, and here you can see different markers we are given as point marker, circle marker. So we'll use circle marker, that is O keyword. So we'll include O, that is alphabet O, small alphabet, before the line style, and we'll run. And as you can see, the different data points in the data set of China population are now populated with the red colored dot on the line style. So, and there are other markers also you can try with. For India I will use different markers, so you can go and see which one we can use. Okay, we'll use star marker. So for that we have to include star keyword. So we'll put star, that is asterisk, and we'll run. And as you can see, the data points in the data set of India is now plotted with asterisk symbol. So this is the one way we can use the format string. Another one is by using the labels or the attributes. So we can put comma and we can type marker. So marker equal to which marker we have to use. So the keyword we have to put in the string format. So I'll put in inverted commas the keyword O, and then the line style we want to include. So type line style equal to in the inverted commas include dash or double dash for dashed line, and the third one is color. So for type color equals to in the inverted commas include R for red color. So we'll remove the earlier format string, and same way we now we'll run, and as you can see the it produces the same result as earlier, and you can see the code is little bit more readable due to the segregation of the marker line style and color into different attributes. So we'll do same thing for India. For marker we'll put star. Keep in mind to include it in the inverted commas because it's a string. So for marker we'll put star, and for line style we'll equals to in the inverted comma we'll include double dash comma, the color will put green, that is G. And now we'll clear the earlier format string, and now we'll run, and as you can see it produces the same result as earlier. Okay, so this is how you use the format strings to customize the plot. One more thing is there for color, we can directly give the values like red, green, that is the complete string, and it will also include that as a valid argument. And also you can also include that is hex value, so you can get it online easily. And now I'll copy it paste. So color one is the particular color I copied from internet, and the second one is for color 2, that is hex value, so I'll put it for China, and now we'll run. And as you can see the colors are slightly different now. I use the shade of red for the China, and for India I use little bit darker in blue color. Okay, so one more thing I want to add is you can also change the line width. So by default it is 2 I suppose, and I'll make it as 4 to make the line little bit thick. And for India we will put it as line width as 3 and put a comma. Save and we'll run it. As you can see the China line is a little bit thick, and for India it is little bit thin than the China. Okay. Mm. Let me remove the line width now. If you are having problems with the screen ratio, like padding is not supposed to be really good with the graph you're plotting, so you can use a function called tight layout. So what this will do is according to your screen resolutions, it will make the plot padding match to the screen resolution so that your plot looks really nice on the screen whichever you're working with. So it will not show that much difference, but if you have any padding issues you can include the tight layout function. Okay, now I'll show you how to include different styles or themes. So for that we have a attribute So we'll type plt dot style dot available. So this attribute contains all the different styles which Matplotlib provides. So we'll include it in a print function. Keep in mind that it is a attribute and not a function, the plt.style.available. So now we'll run the program, and as you can see in the console below, the list of different styles, plot styles are available. So here you can see Seaborn, we have classic, we have. So let me choose one for demo. We'll stop the program first. Now I will show how to use that. So type plt.style.use. So in this function, provide the style value as a string. So we'll start with dark background. So this produces a very dark plot with white color edges. So let me stop the plot first and then we'll run it again. Now we'll use another method, another type, that is 538. So here you can see it creates a graph. So this looks a little bit more nicer, and you can see we have included a grid, but it is not showing us. Let me remove the colors first. So let me see what the theme provides. Okay, so theme provides these colors. So these are very bright and nice, as you can see. Okay, so now we'll use another style, that is Seaborn dash dark grid. So let me copy it and we'll paste it in the style string. So now we'll run. So this is little bit different, as you can see it provides us dark background. Okay, and colors are also different. Now you can see we have included a grid function, but it is not providing us with the grid. So for that put we have to include true as a value in the grid function, not as a string but as a value. So as you can see, it creates a grid and displays it along with the style we are using. Okay, so for me the personal favorites are 538 and another one is ggplot. So ggplot was basically derived from the R programming language. So we'll include that and we'll see how it looks, and we'll run now. And as you can see, it is similar to the Seaborn dark grid. Okay, and we'll now close it, and as you can see, this is how you can use different styles. So one more thing I want to show you is there is one function which is provided by the Matplotlib library, which creates comics like graphs. So for that we have to include plt.xkcd function. So if we run, our graph will be displayed in the form of hand-drawn plot. So as you can see, it is like little bit different, and it looks like drawn using hand. So this is helpful if you are putting it informal way or sharing it with your friends. Okay, so I'll clear all the markers and the line styles. So now we can run and we can see our default graph with no markers, no line styles in the XKCD format. So this is how you use the styles and different format strings for plotting the graph. Thank you for watching. I will see you in the next video. Hello and welcome to another video. So in the last video, I have shown you how to draw a simple plot using plot function provided by the Matplotlib library. So in today's video, I will be showing you how to use subplots to draw more than one plot, and also I will show you how to draw bar charts using the data. So let me run the what we had done in the previous video. So we had drawn this simple plot which has years from 1950 to 2030 and population in billions in y-axis. So we had drawn for Indian population and Chinese population. So let me show you how to use subplots. I will show you how to plot two subplots in the same adjacent plane. So we'll first remove this xkcd function and let me use some style. So we'll use ggplot for this video, and we can just comment out the plot function first. Okay. And now the subplots are plotted as in a way of matrix. So if you want to plot three plots, so what it does is 3 into 1, so that will be in the matrix form. That is, in the first row it will have 3 plots and it will have first subplot. So like that, in the matrix format it will be like 2 and 1, 3 and 3. So these are passed as parameters to the subplot function. So let me just show you. So we'll type plt dot subplot. So in that we'll pass our first one row and we'll display two subplots, 2 comma first subplot. Okay, this is like indexing. So we'll give the plot function now, and inside that we'll pass our year, comma population of China, comma label equal to China, comma color will give it as orange, or not orange, red will give. Okay, so we'll give plot dot title, that will be subplot 1, and our x label, y label will give it as year, and y label will be population millions. So same way we'll type it for subplot 2. In that we'll pass 1 comma second subplot, so, comma 2, and we'll type plt dot plot function. In that we'll pass year, comma population of India, comma label equal to India, comma color equal to green. So remember, we have to pass the legend function on top also, below the first subplot, and we'll type title. So plt dot title will give it as subplot 2. And just copy the x label and y label from top. Okay, and we'll save and we'll run. So as you can see, we got two subplots, and in one we have China and another one is India we have. Yeah, but you can see that one is little bit bigger and one is little bit smaller, the grid function. This is, I think, the due to the values which are passed. Okay, so this is how you plot two subplots side by side. You can also try with different method like style, that is 538. So let me see that how it looks. Okay, so this looks really nice. So this is 538 style. Okay, so we'll create a new file for bar charts. So we'll type bar chart. Yes, and as you can see, also it is added to our Git repository, and also I have uploaded for subplot. We'll copy the data from our main file to the bar chart. Okay, that is year, population, China, India, and we'll get ending lines. Place it here. Okay, we can just directly plot the bar chart using bar function. In that we'll pass the same year, then population of India, comma, label equal to, we'll pass India, comma, color equal to green. Okay, so same we'll copy and paste it here, and here we'll pass population of China and we'll make it label as China, and color would be gray, red. So if we now run this file, we'll get bar chart like this. Our China bar chart is showing perfectly, but our green colored India's bar chart is like little bit showcasing. This is actually happening because the China bar chart is overlaying on top of India's bar chart. Let me show you. So for that we can use a method that uses offset to separate out the values. But first what we'll do is we'll trim down our data, so will only contain values from 2015 to 2025. So for that we cancel out this. Okay. Okay, so now it is done. Let me comment this out. You can run this. It will give a bar chart. Okay. So what if we want to draw one more bar chart? So if we run, we cannot see the green one. It is overlaid by this China's population.
So for that we have a method to overcome that. So for that we have to use something called as width. So by default it is 0.25, I guess. Okay, and we also have to pass indices. We create a variable called indices, and in that we pass the function from numpy and p dot a range, and it will contain the length of our. This should actually come on top right here. So it should contain our year list. Okay, so we have not imported numpy yet, so we just import it. Okay, the numpy is imported, and what we have to do is we have to pass the indices in each and every function of bar. So we'll type indices comma here, and again indices comma here. So if we run it again, we'll see full red color because these indices are not properly set up to work with our years in particular. So it is just giving us the index from 0 to 10. Okay, so what we'll do is we'll, for first bar we'll do indices minus width. For the second we'll keep it as same, and we'll pass width equal to width, so that the function will know that we have changed the width value, and also we'll include, just to open the subplot, our title in the next label and y label. So this will be for first one, and for will not require for second one. Just paste it below. Okay. Type population comparison between India and China. Okay, so if we run this now, okay, we got an error. It is saying we got multiple. So we forgot to remove the year because we are already passing it through the indices. So we'll remove here, and we'll also remove here from here. And if we save and if we run, we can see the India versus China comparison, but years are still showing as indices. So for that to work, we have to pass a function called pid.xticks. So in that we have to pass ticks as parameter. For that we'll pass our indices variable and comma. We'll also pass label equal to the year. And if we save and if we run, you can see our years are shown here. You can see the growth is increasing, and actually at around 2022, 23, 24, India is like near to China. In 25 it will cross to China, I guess. So this is how we plot a bar chart, a vertical bar chart actually. So I will see you in the next video.
Hello and welcome to another video. So in today's video you will be learning about stack plots. Stack plots are also called as area plots. So let's get started. Area plots are pretty much similar to the line plot. These plots can be used to track changes over time for two or more related groups that make up one whole category. For example, let's compile the work done during a day by a student. So we'll go in our project and we'll create a new Python file. So we'll give our Python file name as stack underscore plot, and then we'll press OK, and we'll copy some starting code from the stack plots from PyChart actually, that is importing the numpy as np, and from matplotlib import pyplot as plt. Then we'll use the style 538, and then we'll copy the plot.show and grid functions, or we'll remove the title for now. Okay, so let's go in data.py. So we have file list here, so we'll copy them and we'll paste it here. Okay, so we'll just plot them using pie chart. So we had already done in the last video lecture. So in the pie function we'll pass a list. So how many list we want to show? So we have 4, so we'll type 1 comma 1 comma 1 comma 1 comma, then we'll close the list, and we'll pass the labels for the list. So first is 8, then second one is sleep. Okay, okay, the second one is actually study. Then we'll close that and we'll remove the extra inverted comma. Then we have code and then sleep. So I will just remove the comma, and I have to place the code in front of sleep actually. So we'll paste it here, remove the comma, and we'll remove the extra commas now. Okay, so this will plot a normal pie chart. So I will show you why I'm plotting this. So we'll type plt dot title. So in that title we'll give as pie chart. Okay, we'll make that h. Okay, and then we'll run this. So for that we'll right click and we'll run stack plots. Okay, so the normal pie chart will give you 4 quarters with study, eat, sleep and code. But this is like so what if you want to show data for 5 days in a continuous manner? So we can't show that actually using pie chart. So for that we'll use this stack plot particularly. So here you can see for a particular day 1, a particular student will have 1 hour of eating and 8 hours of studying, 6 hours of coding, 9 hours of sleep. So like that we have 5 consecutive days. So you can see second day he has 3 hours of eating, 5 hours of study, code for 8 hours and sleep for 8 hours, like that. So what we'll do, we'll remove the pie function. So we'll type plt dot stack plot. We'll open the parenthesis. So inside that we'll pass our list. So our first list we want to show is days actually. So you can see the data in the eat. We have actually our data is increasing in study list and in sleep. So what we'll do, we'll pass first days as a parameter to stack plot. So this is a list. Then we'll pass 8. Then we'll pass study. then code, and then sleep. Okay, so that is enough, and we'll change the title as stack plot. Okay, stack plot, and now we'll right click and we'll run the file. So if we run it now, it will load. You can see that it is showing us the data for 5 consecutive days. On x-axis we have days, and on y-axis we have hours. So you can see we have not given the labels actually, so we are not finding which one is what. So you can see the we'll just close it and we'll just put the labels now. So we'll create a list for labels. So type labels equal to, so we'll open the square brackets and we'll pass the string. First label is eat for our first list, then we have sleep, not sleep actually, we have study, then third one is code, and then the fourth one is sleep. So we'll pass these labels in the stack plot as parameters. So labels equal to labels, that is our list. And if we run it now, so before running we'll type plt.legend. So this is very much important. So what this will do, this will print the labels on the screen so that we can find it as which color is pertaining to which particular label. So you can see blue is for eat, then orange is for study, and on y-axis we can see the hours, and x-axis we have days. Okay, so we have, then blue color we have this 8, which is actually decreasing. In middle for third day it was like 4 or 5 hours, and then the study you can see it is increasing in the order, and the code is actually decreasing till we reach the 5th day, and the student is actually getting more sleep by the end of the 5th day. So you can find it. Okay, so another thing is we can change the location of the stack plot legend. So we'll type in the legend loc equal to where we want to show that. So we'll type upper left, so upper space left. So this is a string that we have to pass in the location loc variable in the legend function. So you can see the location of the legend is changed now, and it is at the upper left corner. Okay, so now what we'll do is we'll create one more list for colors. Here you can pass hex code also, that is hexadecimal codes, and also the short form or short characters. So we have M for magenta, C for cyan, R for red, and K for black. This I already showed you in my earlier videos. You can refer them. So we'll pass that list as colors equal to colors in the stack plot function. So we'll remove the extra spaces, white spaces, and we'll run it again. We'll run it again. Okay, we'll also put tight layout just in case for nice padding. So plt.tight layout. Okay, so now we'll right click here and we'll run it again. So here you can see our colors are changed and it looks really nice now, really vibrant. Okay, so magenta is the 18 hours, cyan is the study hours, orange or kind of red is coding hours, and we have black for sleeping hours. But you can see our legend is little bit off the grid, it is little bit getting outside, so we can fix that. So what we have to do is in our legend for loc variable we'll remove that string, and instead of that we'll pass a tuple. So how you create a tuples, we have to just open and close the parenthesis, and inside that we have to pass the x and y
coordinates or percentage uh, by which we want to shift the legend. So we'll pass 0.06, that is not actually 6%, that is 0.06%, and also that is from left, and from the bottom we will pass 0.06%. So now save it, run it again. So you can see our legend is now shifted towards the little bit inside of the area plot, and you can see it is nicely put. So by this is how you can customize your stack plot. So this is just one example. You can do more kind of this using stack plots. You can actually create stacked stack plots. Those are actually sit one top of another. Okay, so as usual I will provide this Python file in my GitHub link in the description of the video. So I hope you like this video. Thanks for watching, and I will see you in the next video.
Hello and welcome to another video. So in today's video, I'll be showing you how to use Matplotlib library to plot a histogram. Okay, so here we'll create a new file, new Python file, and we'll type histogram and press enter. Okay, so our file is open. So first we'll import the matplotlib library. So import matplotlib.pyplot as plt. So we are importing plot function from matplotlib library. Okay, so now we will open our data file. So in here I have a list which contains blood sugar levels of patients. So this is a string which contains data. Okay, and so diabetic blood sugar levels range I will show you. So if the range is from 80 to 100, then the person is a normal person and he doesn't have diabetic. And if it is from 100 to 125, then that person is pre-diabetic patient of diabetics. And if he has above 125 blood sugar level, then he is a diabetic person. So we'll plot the histogram using the above chart, above list. Okay, let me comment this first. Okay, so below this plt dot hist, like this histogram function, and open curly parenthesis, open and close parenthesis. So inside that we'll pass our list, that is blood sugar. Okay, so we'll run this particular file, histogram.py, right click and run. Okay, we forgot to add show function in order to show the histogram on screen. So we'll type plt.show and open and close parenthesis. So stop and we'll run it again. Let me check. Okay, so now we can see our histogram is loaded. So by default you can see it is taking the scale from 80 to 150, because that is the highest number of value. 150 we have, from less than 80 to 150, and there is the number of people in y-axis. So matplotlib implicitly has plotted 10 number of beans. So beans is actually the number of bars in particular histogram, you can say that. And now we'll customize the beans. So we'll type beans equal to, we have 3 categories, so we'll type beans equal to 3, and we'll pass that beans into the histogram function. We'll type beans equal to the variable beans, and If we run it again, we can see that we are presented with only 3 bins, and you can also categorize them using a parameter called edge color. We have already used in other graphs. So edge color equal to, we'll pass the string as the name of the color we want to press, like we can pass G for green. So here you can see, like we can't see it clearly, so we'll make it R for red, and we'll run it again. So here you can see our beans are surrounded by a edge color of red, so that we can easily distinguish between these beans. There is one more parameter which we can use, so I'll show you that. So let me remove the edge color first. Okay, so we'll type R width equal to 0. We'll type 8. So R width is actually relative width, that is relative to the beam we are targeting, so that it will provide a gap between 2 beans. Let me make it explicit. So we'll type beans equal to a list. So inside a list we'll pass 80, 100, 125. So these are the 3 categories, and the 4th value will be the highest number of category value. So we'll pass it as 150. So we'll pass that list into the beans equal to the name of the list, that is beans. So as you can see, now it is recognizing the values we have passed in the beans parameter or beans list. So it is starting from 80 to till less than 150. So this is how you can customize the beans to have a particular category. And also you can play around with the R width. So we'll make it as 0.95, so that you can see that now the width between the 2 beans is decreased. So 1 means there will be no gap in between the 2 beans. So we can also pass color parameter. So color equal to, we can pass G, or we can pass green inside as a string. So if we run, now our beans color is changed to green, as you can see. And I will also show you how to make the beans as hollow. So we'll type hist type equal to step, and the step is a string, so we'll enclose it into the single inverted commas, and you can see our beans are now hollow. So I will remove that and show you again by rerunning the program. And if you see now, you can see that those beans are filled with color, and we provide the hist type as step, then it will be hollow and it will look like steps. So that is how we can customize. Okay, now we'll open our data file, and I will pass 2 strings or 2 lists actually. So one is for blood sugar of man, and another one is for blood sugar of woman. So this is 2 static data, the list. So we'll copy and paste it here. Okay, and now we'll pass those 2 list into our histogram function. So we'll type blood sugar of woman and man. Okay, so instead of directly passing it here, we'll make it as a list and pass it here. So let me cut this both of these list from histogram function. Okay, then we'll create a separate variable called type, and inside that we'll create a list, and in that empty list we'll pass our both the list. So now if you type type in the histogram function, so it takes both the list into the histogram function. And also we'll pass colors equal to a list. Inside that we'll pass G in inverted commas, and R for green and red for the colors of both the list. and we pass color equal to colors in the histogram function. So if we run it again, we can see that the green and red color beans are displayed on the screen, but we are not knowing which one is man and which one is woman. So for that, we'll pass the tangent function and legend function and also the title. So we'll pass plt.title, and inside that we'll put string as blood sugar level chart maybe, and also we'll put labels. So we'll go on top, and after colors we'll type label equal to, inside that we'll pass an empty list, and in empty list we'll type the string which one we want. So we'll type man and woman. So let me enclose it into the inverted commas. Okay, so now we'll pass this label into the histogram function by invoking the label equal to label variable. Okay, so if we now run it again, before that we have to type the legend function. So plt.legend. So you can see the green one is man and red one is woman, but we forgot to add x and y labels, so we'll add that in a minute. So you can see in y we have number of people, and x we have blood sugar range. So we'll after beans we'll type plt.x label for labels to be displayed on x-axis. So it is a function, and inside that we'll pass a string. So we'll type blood sugar range, and for y label we'll type plt.y label, and inside that we'll pass a string as number of patients, total number of patients. And if we run it again, we can see the x and y labels as total number of patients and the blood sugar range on the x-axis and y-axis respectively. So we'll close this. So using the histogram we can compare the values. So you can see for normal 6 men are there, and in pre-diabetics we have very less number, that is 2, and as compared to the diabetic people, the normal people are more, and women's normal people are more, and diabetic women are less. So this is how we can compare and analyze the data using the histogram. So in the future I will show you how to utilize the pandas library to display the histogram in a very efficient manner. So that's all guys, thank you for watching. Before that I will also show you how to change the orientation. So for that we'll type orientation equal to it is a string, so we'll type double inverted comma and we'll pass horizontal. So this we have to pass in the histogram function. Okay, so if we run it again, you can see the x and y axis are changed. So total number of patients is now on y axis, and blood sugar range is on x axis. So this is how you can change the orientation of the histogram. So thank you guys for watching, and I will see you in the next video. So now we'll get to our data visualization using the different libraries like Matplotlib and Seaborn. So I will show them how to do it for the files like CSV, etc. Okay, we got our new notebook. Let's just name it as data visualization in data science. Okay, and now what we can do, we'll import the necessary libraries, import OS, then import
numpy import. We'll add one more cell and add os.chdir. We have to give the, just copy from, we'll just copy the, yeah. So what we need, this directory. Okay. And now just we'll os.list dir. Now what we can do, we'll create a new data frame, cars data, and just get the toyota.csv index column equal to 0. We'll exclude the special characters. If we run this, we got, okay, we have to import the pandas also, forgot. Yeah. So now what we can do, we have to do data visualization. So just add a new cell. I will show you how to mark down this. So for markdown, what we do is, if you want h2, that is heading 2, we can just type 2 hashes, and you have to select markdown, and then give data visualization. Okay. Cbon. Okay. If we run this, you can see it is now printed in h2. So what is data visualization? So data visualization, you can say, it allows us to quickly interpret the data and adjust different variables to see their effect. And technology is increasingly making it easier for us to do so. So you can get more insight by looking at the graphs, the plots. So data visualization is very important for data scientists. And why you visualize the data? To observe the patterns and to identify the extreme values that could be the anomalies. Anomalies in the sense, the outliers, which are not related to the data, and then easy interpretation. So I'll show you how to do this. First, let's understand what are the different options we have in Python. So the popular plotting libraries in Python are, Python offers multiple graphing libraries that offers us diverse features. So one of them is Matplotlib. So these ones I have marked in green, Matplotlib and Cbon. I'll show them in this tutorial. So Matplotlib provides us to create 2D graphs, two-dimensional graphs and plots. It comes very handy for data scientists. Then we have Pandas visualization. So Pandas also provides us the visualization capabilities. It has an easy to use interface and built on Matplotlib. Then we have Cbon. Cbon is based on Matplotlib only, and it provides high-level interface for drawing attractive and informative statistical graphics. Then we have ggplot. So ggplot is actually based on different programming language called R. So in R we have ggplot2. So it was inherited from R's programming language into Python as ggplot. The full form of that is grammar of graphics. And another library we have is Plotly. So I will not show it, but it is can create interactive plots. So I'll give you an overview of Matplotlib. So Matplotlib is a two-dimensional plotting library which produces good quality figures. I have an entire playlist made on Matplotlib. I will give it in the description so that you can go ahead and watch it. Although it has its origins in emulating the MATLAB graphic commands, it is independent of MATLAB. If you don't know, MATLAB is very famous in the science community. It provides you simulation, etc. And they have a particular language for MATLAB. It is different from our Python or some other languages. So it makes heavy use of NumPy and other extension code to provide good performance even for large arrays. So this is the overview of Matplotlib. So in Matplotlib, I have shown you different plotting graphs, etc. So one of them was scatter plot. In the earlier video also, we have seen the correlation. In that I have shown you the price and age
correlation, negative correlation, etc. So I will show you what is the scatter plot actually. So scatter plot is like, it is a set of points that represents the value obtained for two different variables plotted on a horizontal and vertical axis. And when to use scatter plots? Scatter plots are used to convey the relationship between two numerical variables. So whenever you have like correlation, etc., you can use these scatter plots to effectively show the relationship between the two variables. And I will show you how to plot the scatter plot. We'll also import our matplotlib. So for that, what we can type, matplotlib dot pyplot as plt. Okay, run this. Now what we can do, we have imported the matplotlib and our data frame is also created using pandas. One more thing here I will do after this, we want to drop all the null values. So what we can do, we can call our data frame, then we will call drop na function, and inside that we'll pass axis. So we want to remove all the rows which contains the null values. So x is equal to 0 means the rows, and x is equal to 1 means columns. And then we'll type in place equal to true. So in place equal to true, what it does is, whenever we want to do some changes in the original data frame, that is the same data frame, we can use in place equal to true. And if you are saving this into another data frame like cars.2, you don't need to use in place equal to true. So that is the difference. So we are not creating a new data frame, we are just storing it in the same data frame. So we'll just use in place equal to true. And now whatever the null values are there in the rows are removed. We'll just get the info. Yeah, so all the columns all the rows which has null values are pruned, and you can see only out of 1435 1096 rows are included. So this allows us to get better insight for data visualization. So let's start with the scatter plot. I'll just add one. Let's make this markdown and just scatter plot. Yeah, and now let's start. So what we can do, we'll call plot or matplotlib library, and we'll call scatter function. And inside that we have to give our rows and columns which we want to use. So for first we want to use the age column, and for the columns, this is for the rows, and another one for columns we'll use price, and we'll use color code as red. Now you can see we got a nice scatter plot. So okay, we have not got the title and the x label, y label, so we'll add that also. So we'll just type plt.title, we'll give title as scatter plot of price versus age of the cars. And now we'll give x label. So x label, it is a function. Inside it will pass the label which you want to pass. So for y label we'll add the price. Let's just say, now you can say we got the title scatter plot of price versus age of the cars, and we got the y label and x label. So these are the points in red. You can see these are called as markers, and you can see this lines, these are called as ticks, and the values which are given are called as tick labels. So these are X tick label, these are Y tick labels, these are ticks, the individual lines. Actually, we have to use a function called plt.show, but it is not needed here. As you can see, the Jupyter notebooks does its job. It automatically shows us. You can see that in the earlier video I shown you this scatter plot, and I have shown you that this is a negative correlation. As you can see, it is coming down. So as the age of the car increases, the price of the car will decrease. So you can see the negative correlation, negative trend. If it was in this direction, then you can say it was a positive correlation. So this is how you can calculate the correlation between two or more columns. Let me show you the histogram. So what is histogram? So it is a graphical representation of data using bars of different heights. And histogram groups numbers into ranges. You can also call it as intervals or bins. And the height of each bar depicts the frequency of each range or bin. So the height of each bar will tell you the frequency, that is the number of time or the count of that particular column. So when to use histograms? So it is used to represent a frequency distribution of numerical variables. So when you have a lot of numerical variables, this is very handy, such as price, then we have weight of the car, age of the car, etc. At that time you can use histograms. Now let me show you how we draw the histogram. So for that we call there is matplotlib. So this is an alias for matplotlib library. So plt.hist function, inside that we have to give the x-axis which we want to use. So I'll give the kilometer for x-axis, and these are the default arguments. So this graph will be created. So let's see how it is done. Let me add new cell here. Let's So we'll directly call plot function plt.hist. Inside that we'll pass the data frame and the column which you want to give. So our histogram is created, but we can't find out which particular range contains which particular value. We can say that there are more than 300 cards, but we can't find exactly in which range they lie. So for that, what we have to do is, in our hist function, after this, put a comma and add, let's say, color we want to change to green, and then there is something called edge color. So what edge color does is it will give a nice outline to the bins or to the bars. So we'll give the outline in white color, and how many bins you want to create. So we want bins of let's say 5. If you run this, you can see we get 5 bins, and it was earlier a mess. So if I show you the earlier one, we can see there 1 2 3 4 5 6 7 8 9 10. There were 10 bins. So by adding this, we created 5 bins and we added some edge color. So you can see that more than 500 cars have actually run for these many kilometers, from 50,000 to 1 lakh kilometers. We have not added some title, etc. Let's just add to make it more readable. So give histogram of kilometer driven. Now we'll add our X label and Y label. In X label we have kilometer, in Y label we have frequency, and we don't need show function. So we can see the kilometer, we can see 50,000 to 1 lakh kilometers. We have more than 500 cars that are drawn, and very few cars have drawn maximum of 2 lakh to 2 lakh 50,000 kilometers. Now let me show you the bar plot. Okay, so what is bar plot? So we had seen the histogram was having numerical variables. It was used for numerical variables and it was in a continuous form, but bar plot is used for categorical variables. So we can have some distance between the two bars. So for that we have bar plot. So it is a plot that presents categorical data with rectangular bars with lengths proportional to the counts that they represent. And when to use the bar plot? So to represent the frequency distribution of categorical variables. So as contrast to the histogram, so which is using numerical variables, we use categorical variables for bar plot. And a bar diagram makes it easy to compare sets of data between different groups. Let me show you the bar plot, how it is done. So you can see we can get the counts of how many number of cars are there of particular fuel type, and we have fuel type that is petrol, diesel and CNG. Then we use index to get the range of the fuel type. So we have 3, so we are getting len function and we are passing the fuel type and it will calculate it is at 3, and that will pass in the bar function for getting the exact bars. So index we are passing for x-axis, so it will create 3 bars, and counts is for the height of the bars, that is the frequency, and the color we are passing red, blue and cyan, and we are given title x label, y label and show function. Let me show you how to create a bar plot. So we can get counts. So for counts, what I can do, I will call the data frame. So we had earlier seen in the pandas tutorial how to get the values count. So we want fuel type column, we call value count function, and if you print this you can see 968, 116 and 12 we got. Okay, now what we can do, we'll get the fuel type. That is equal to, we'll call numpy function, numpy library, and we'll call unique function, and what we can pass in inside it is the data frame and the type of column. So we want to target fuel type. If you print the fuel type, you can get the CNG, diesel and petrol. Now we'll get the index. So index we can get from numpy library. So in that we have a range function. So it will calculate how many values are there in particular column. So we had fuel type here. So we'll pass that fuel type. So it has calculated. Now we'll draw the bar plot. So we'll start with the pit.bar function. Inside that we'll pass the index, that is how many columns or how many bars you want to create, and then the counts, that is the frequency distribution, and the color. We'll pass a list. We already know there are 3 bars, so we'll give 3, red, green and cyan, and then we'll give title bar plot of fuel types. Now we'll give our x label, and x label will be fuel types, and then we'll give our y label. So y label would be the frequency, and that is enough. You can see we got bar of fuel types as title, and you can see near 1000 we have fuel types of red color, green color, and cyan, and we can't see exactly what is wrong with the fuel types. It is giving us minus 0.5, 0.0. So let's just fix that. So for that, what we can do is we have to add something called as xticks. I had already shown in the earlier histogram that xticks actually helps us to set these values. So in xticks we'll pass index, that is how many bars we want to create. Then we'll pass, so index will pass the location for the xticks to show us, and next would be fuel type. So these are the labels which we want to show on our bar chart or bar plot. Then the rotation we want to have, so we'll give rotation equal to 90°. And if you run this, now you can see we got CNG, diesel, and petrol for each of these categorical variables. One thing I have to show you here is that CNG is not the fuel type which has the highest number of cars. It is actually petrol. So let's see where our bar plot went wrong. If you run this and type print counts, then you can see petrol is the highest here. 968 has the petrol fuel type. So I think something went wrong here. So if you print fuel type, we get CNG, diesel, and petrol. This should be reversed. So how we can do that? We can do fuel type. So this is a numpy, actually numpy array. So what we can do is fuel type equals to, we'll call fuel type array, and then we'll call this list, and then what we can do is for all the elements by -1, so this will reverse the order. So if we now check for the fuel type, you can see petrol, diesel, and CNG. So this is how we should troubleshoot when you got any errors or any misrepresentation. So now we got correct representation of the data from the toyota.csv file. So we can get petrol as the highest number and diesel and CNG. You can see the numerical variables kilometer, age, and HP are filled with the mean, median values, and there are no missing values for these columns, and only now remaining is fuel type and mat color. So these are categorical variables. So now we'll look at how to fill the categorical variables. So as I already said, for categorical variables, what we'll do, we'll find the most frequently occurring the elements, and we'll use those to fill those particular missing values. So this is actually called the model class. So which class has the most frequently occurring elements, so we'll use that class to fill other class variables that are missing. So we'll use the series.value counts function. So series is data frame here, dot value counts, and what it will do, it will return a series containing the counts of unique values. The values will be in descending order, so that the first element is the most frequently occurring element, and then we will exclude any values by default. So let's check how many values are unique. So we'll check for fuel type, we'll call cars data, and inside that we'll type fuel type, and we'll call the value count function. If you run this, we can see we have petrol as 1177, diesel as 144, and CNG as 15. Okay, got that value. Now what we can do, we'll use index 0. So we select that and we'll fill in a all the other missing values with that particular fuel type. So for that, we'll call fill function, and you don't need to do this stuff because we have already got a count as 177 for petrol. So obviously petrol is the most frequently occurring category in this column of fuel type. So we'll use fill function. Inside that we'll use value counts, then the index is 0 to fill the values. So we'll use cars data function, data frame. Inside that we'll use the fuel type which we want to fill. We'll use fill function, and it will contain our data frames column which we want to select. So we have cars data, inside that the column that is fuel type, and then we'll use the value counts so that we'll get the most frequently occurring category, and then we'll use index as 0 so that we'll know that it's the petrol. We'll select the 0th the index element or category, and press enter, and we'll give comma in place equals to true. Check if it is correct. Yes, it is correct. And now we'll fill the values with the petrol category. And now if you check for the fuel type, if it is filled or not, we'll use is null or is any function, and then we'll call the sum function. If you run this, we'll get 0. So same way we'll go for the next column, that is matte color. So matte color, you can see we have two values, 0 and 1. So we can also use, instead of value counts, we can use mode function. So let me show that. So we'll use cars data, and then we'll use matte color, and then you use the mode function to get the most occurring element. So we have 0 and 1 which are occurring most. So we can also use, instead of that, value counts. So you can see 1 is appearing 868 times and 0 is appearing 418 times. So this is a boolean category. We'll use 868. Let me just copy this and just paste to confirm that mode is right. So mode is saying 0th position, that is 1.0. So what we can do, we'll use the same function, we'll copy this to save the time for ourselves, and then we'll use matte color instead of that, and same way we'll matte color, we'll put it here, and instead of value counts we can do mode at index 0, and if you run this will fill the values with missing values with the correct. Just we'll do what, we'll just call the data frame, and we'll use describe. Not describe, we directly call is null function, and we'll use sum function to get the details of all the columns which are missing values. So we have filled all those different columns like numerical columns and categorical columns with the appropriate values while putting logically. We can also do it by using lambda function. So to fill the null or NaN values in both numerical and categorical variables at one stretch, what we can do, we can call apply function, and inside that we'll pass the lambda, that is anonymous function, which has x and x.fillNA, and we can pass x.mean if x.dtype is equal to float. Else what we can do, x.fillNA, x.value counts dot index as 0. So the first if condition is for numerical variables and the second if condition is for categorical variables. So we can try that. So what we can do, in the earlier we had created one copy. Here you can see. So here we'll use cars data 1 equals to df dot copy, and we'll run this. We'll go down. Okay, so we have cars data 1 dot is null. We'll check if it is containing the missing values. Yes, we got missing values in all different categories of columns. So what we can do, you just use the lambda function. So I'll call the data frame data 1 equals to cars data 1 dot apply function, and inside it we'll call lambda function lambda x in. So we'll use x dot fillNA, and we'll pass the first column which we want to select. So we'll use mean if in case of the numerical variables. This will happen if x dot dtype is equal to float. Else what will happen is we'll use x dot fillNA with x dot value counts. You can also use mode. Then we'll have index, we'll have 0th. So we forgot one. This is function, so we'll just run it again. So now if you try to get, if you run this again, you can see all the missing values are filled. For numerical variables we have filled it with mean, and the other categorical variables we have filled it with the model class. So this is how you do with the lambda functions. So you can do it at a one stretch. So what is the summary of this lecture? So what we have done, so we have identified the missing values in a particular data frame. Then we have found out the different approaches to fill the missing values for different types of columns. So first one we had seen numerical columns, in which we had filled the missing values in the age, the HP, price, and the second one was the categorical columns. So in the mat color and fuel type we had filled all the missing values with the model class or the most frequently appearing class. So thank you for watching. I will see you in the next video.
Hello there, and in today's lecture you will learn about how to do data visualization using Seaborn library. So we'll learn how to create basic plots using Seaborn library. So those plots are scatter plot, then we will do histogram, then we'll do bar plot, then box and whiskers plot, and then pairwise plots. So let's get started. So Seaborn, what is a Seaborn? So Seaborn is a Python data visualization library based on Matplotlib library. So it provides a high-level interface for drawing attractive and informative statistical graphs. So let's see how to do a scatter plot using Seaborn library. We had already seen in the Matplotlib library. So scatter plot of price versus age we will do in this, and then with default arguments. So first what we have to do is we can call the Seaborn library by calling SNS, that is alias for Seaborn library. I will show you how to do that. Then sns.set, first we will set the style or theme for the plot. So style equal to dark grid, so we'll use dark grid theme. Now we'll draw the scatter plot. So for that we have to call a function called regplot. So that is a regression plot. So inside that we have to pass our x coordinate. So I am passing x equal to cars data age. So this is the column from the data frame, and in the y-axis I want price, so I will pass y equal to data frame and slicing operator and the price. And if we run that, we will get this plot. So this is scatter plot, and along with that you might have noticed there is a line here. So this line is called as regression line, and by default that line is true. So for that a variable is used, that is fit underscore reg equal to true. So by default it is true, that's why the line is displayed here. If you want to remove it, you can just add it here along with the regplot function, that fit reg equal to false. So what it does, it estimates and plots a regression model relating the x and y variables. So it calculates the coefficient of x variables and plots a line through the scatter plot. Let's go to our Jupyter notebook, and here we have to import the Seaborn library. So for that type Seaborn as SNS. So SN is a alias for Seaborn library. So whenever we have to call any function from Seaborn library, we will call SNS, then we'll call the function name. Now we'll start the scatter plot. We'll just change to markdown, and now what we can do, we'll set the theme. For that we'll call set function from SNS, and we'll pass style equal to, there are many styles, so I will use particular dark grid. This is default style also. And now we'll draw the regression plot or scatter plot, you can see. First we'll pass the x-axis. So for that we will call our data frame, then a slicing operator. Inside that we'll pass age. Then for y axis we'll call the price column, and if we run, along with the warning, we got our scatter plot. So you can see we have a regression line here, and you can see the negative correlation. As the age of the car increases, the price of the car decreases. So what we can do, I'll show you how to remove that line. For that we'll pass fit reg equal to false variable. Now you can see the line is not present. So these are called markers, and these 0, 10, 20, 30, these are called x ticks labels, and these are y ticks labels, and these are pertaining to price, and these are pertaining to age. Now let me show you how to change the marker. So we have default marker, that is a circle. You can change the markers also here. For that we'll set the marker variable, and it will take a string and will pass star. And if you run this, now you can see all the circles are changed to stars now. So there are other parameters also, so there are options for markers also. You can go through that in the documentation. I'll give the link in the documentation. Now this is for two variables, price and age. So if you want to for three variables like field type, so these were two numerical variables. So what if you want to add one more categorical variable? So for that, how we can do, I will show you that. So if you have scatter plot of price versus age and you want to do it by field type, so you can do that. So for that you have to use a parameter called hue parameter, including another variable to show the fuel type categories with different colors. So there is a function for this in Seaborn library called lmplot. So this helps us to add another categorical variable in the numerical variables scatter plot. So for that we'll pass x equal to age, y equal to price, and data equal to cars data. So this is a data frame, and when we pass data equal to cars data, the x and y axis are automatically taken from this data frame as age and price. You don't need to use slicing operator. And now we'll do fit drag equal to false. We don't need the regression line, and then we'll pass u equal to fuel type. And we also want legend, so to know which fuel type is which color, we will include legend equal to true. And the palette, that is a colors scheme which we'll use, is set 1. So I will show this by running. We'll type sns dot lm plot. Inside that we'll include x equal to age, comma y equal to price, comma data equal to the data frame. We have cars data, comma, then we don't want regression line equal, so fit drag equal to false. Then the hue parameter, we have hue parameter as fuel type. Then legend we want equal to true. Then palette, so palette we are setting as set 1. So these are predefined values. So if you run this, we got a nice plot along with the fuel type. So we can see fuel types, so these are called legend, and the red color stands for diesel fuel type, green color stands for CNG, and blue color stands for petrol. So you can see there are more number of blue colors, that is petrol fuel type. And you can see as the age of the car increases, the price of the car decreases, that is negative correlation. Along with that, the prices of the car is very high for diesel fuel type when the age is very new, and as the age of the car increases, for all the fuel types the price of the car decreases. So let's get back to our slides, and you can also change the scatter plot by using the different markers such as transparency, shape, and size. So you can increase or decrease the transparency, the shape of the data points or the markers, and the size of the markers. So this you can get through the documentation. So for Seaborn docs, if you go, there is a whole lot of documentation provided. So what we can do, we are doing for, so markers, if you search, if you go seaborn.scatterplot, so you can get the color palette. And if you go down, so markers you can change. So these are some examples given here. You can see you can get the legend inside the scatter plot. You can increase the size and decrease the size. You can give sizes equal to 20, 200, like that. And there are different palettes. You can select CMap, etc. I'll encourage you to go through the docs also to get better understanding of different types of plots and how to draw it. And I will give the link of the documentation in the description of the video. Histogram. So how to draw histogram using Seaborn library. So for that, there is a function called distplot, and inside that we have to pass the variable which we want to include. So for the x-axis I am giving age, and histogram is by default includes kernel density estimate. So what is kernel density estimate? So it is the curved line along the bins or intervals or ranges of the frequency of the age. So let me run this. And now we'll call the SNS library and we'll call distplot. Inside that we'll pass cars data equal to or slicing operator age. If you run this, we got plot along with the kernel density estimate from, you can see the 0.000 till 0.025, and this is the line which is created, and you can see we are not getting the frequency exactly, we are just getting the kernel density estimate. So if you want to remove the kernel density estimate, what we can do, we'll just pass KDE, that is kernel density estimate variable, equal to false. If you run, you can see now we got the frequency as y-axis and age of the car as the x-axis. So age in the months format, and you can see for 60 to 80 months, that is 5 to 6 years, we are getting maximum number of cars. So that is from 100 to 140, more than 140, and that KDE is now gone. So now let's show you how to regularize this. So for that we can create bins equal to file. So what it will do, it will organize all the different intervals or bins into 5 bins. You can give as many bins if you want, but to better understanding I am giving 5 bins. And now you can say from 65 to 80 we are getting more than 400 cars. And now let's see how you can draw bar plot. So bar plot we had earlier seen in the Matplotlib library, it was for categorical variables. Same way we will do for SNS Seaborn library. So here categorical variable is fuel type. So this is another way to write the x-axis. So we'll call count plot function. Inside that we'll give x equal to fuel type, and then we have to give the data frame name. So data equal to cars data. And this is the way by which we don't need to use the slicing operator along with the column. So this will create a bar plot for the frequency distribution of fuel type of the cars. So let's do that, and I will show you how to do it. So this is bar plot, and it is marked down, and if we run, now let's use the Python library SNS dot count plot. We'll give x equal to fuel type, and then data equal to cars data. As you can see, we got a nice bar plot which has diesel, petrol and CNG as fuel types, and you can see petrol has the maximum number of cars and it is near 1000, and CNG has very less, and diesel also has very less, that is around 100 cars. Now let's see how to do the grouped bar plots. So grouped bar plots actually is, we are including one more variable along with the fuel type. So group bar plot of fuel type and automatic. So we'll include the transmission medium of the car, manual or automatic. So for that we are including x equal to fuel type, and then the data frame into the data variable. Then we are using hue. So hue parameter is used for adding one more variable. So here we can do hue equal to automatic. Since categorical variables, we will need one variable for y-axis, so we are not touching the y-axis, we are only including hue equal to automatic. So I'll show you that. If you copy this and if you add hue equal to automatic, now you can see we got a legend here. So automatic, in the blue color, if we have, in the blue color we have manual transmission, that is 0 value. So you can see petrol has the maximum number of manual transmission cars, it is more than 800, and diesel has around more than 100 manual transmission cars. CNG is very less. But if you see the automatic transmission cars, petrol has somewhat around less than 100, but diesel and CNG doesn't have any cars which has automatic transmission inside it. So this is how you can do the grouped bar plot for having more than 2 variables inside the bar plot. Now let me show you So in pandas we had done cross tab to get these values inside a table. So the same thing we have done here using the visualization library. So there we had done index equal to automatic column and columns equal to field type column, and we had included drop n equal to true, and we got this result. Now let me show you the box and whiskers plot. We'll do first with numerical variables. So what box and whiskers plot of price will visually interpret is, it will give us the 5-number summary. So what is 5-number summary? So 5-number summary includes minimum, maximum, 3 quartiles that are 25%, 50% and 75%. So if you remember, I had given in pandas library the 5-number summary how to do that. So we had done like the cars data dot describe. We had got this 5-number summary. Here we have minimum, maximum, 25%, 50%, 75%. So this was using the pandas library. Now we'll see the 5-number summary using the data visualization library. So for that we will use the box and whiskers plot. For that we'll use price. So how to do that? So we'll call box plot function from Seaborn library, and we'll give the y-axis as cars data price. So why we do the y-axis as price? If you want it to be vertical, we can use price in y-axis. If you want it to be horizontal, we can use in the x-axis. So it's better to use in y-axis. We get exact details. And why it is called box and whiskers plot? Because it contains box and these lines are called as whiskers. So this is lower whisker, this is upper whisker. Anything above the whiskers is called outliers or extreme values. So these values are not included because they supposed to be very far away from the middle values of the data set. So let me show you how to do this. So let's make it markdown. Now what we can do, we'll call sns dot box plot. Inside that we'll give y equal to cars data. Inside that we'll include price column. If you run this, we got the box plot, and you can see lower whisker and upper whisker. So lower whisker is around 5,000 euros and upper whisker is around 16 to 17,000 euros. And so this lower box plot whisker is called as first quartile, and middle one is called second quartile, and the final one is called third quartile. So what is first quartile? It is the 25% of all the data values inside the box plot. So it is near to 7,500, and you can see the second quartile. This is called median. So median lies for 10,000 euros, and you can see the 75%, that is third quartile, it is near the 12,500, and these are called extreme values, and these extreme values lies above 1.5 times the median values. So now I have shown you for numerical variable. Let me show you box and whisker plot for categorical variables versus numerical variable. So this is how you do the numerical versus categorical variable. So we'll pass x equal to cars data fuel type. So this is a categorical variable, and the y-axis will give price, that is numerical variable. So this is price of the car for various fuel types. So for that we'll call sns alias, and then we will call box plot. Inside that we'll give x equal to cars data, then the slicing operator, and inside that we'll give the fuel type, and then for y we'll give cars data, and the slicing operator. Inside that we'll give price. Shift enter, and now our price versus the fuel type of different cars is drawn. So you can see in the box and whisker plot of this, the median of petrol fuel type is more than the diesel and CNG. So more number of cars have median price more for petrol fuel type. And you can see diesel has the minimum valued cars. So you can see the lower whisker for diesel fuel type is less than the petrol and CNG, and you can see the upper whisker for diesel also, it is higher than the petrol and CNG fuel type. So this implies that diesel has the lowest valued car and highest valued car, and also the diesel and petrol has the outliers, whereas CNG doesn't have outliers. So median is around 10,000 euros for petrol, and it is around 8,000 for CNG, and it is around 9,000 for diesel. Now we can also include one more variable, so that will be price versus fuel type versus automatic. So how you can do that? So we have to include hue parameter, then we have to pass automatic. Let's just copy this to save time, and instead of passing this as slicing operator, what we can do, we'll include one more parameter as data equal to cars data. Next is hue parameter equal to automatic. So this would be price versus fuel type and automatic. And if you run this, we are getting a grouped box and whisker plot which contains price versus fuel type and the gear transmission. So we can see there are no automatic gear transmission cars for diesel and CNG, whereas we have for petrol. So maximum value for petrol fuel type cars which has automatic transmission is higher as compared to other type of cars which has manual or other fuel types. And we can see that the lower whisker for petrol automatic transmission car is also high, and we can see that upper whisker for petrol fuel type automatic transmission car is higher than the rest of the manual transmission cars of different fuel types. And also you can compare the petrol fuel types automatic transmission and manual transmission, and you can see the difference in both of them. One has the upper whisker more, and that implies that there are more number of cars which has higher price for automatic transmission, whereas the manual transmission cars of petrol fuel type doesn't have that maximum valued car. So now we'll look at how to draw two plots in the same window. So we'll draw box whiskers plot and histogram. So let's see how to draw them in the same window. So what we'll do, we'll split the windows into two parts. For that we have a function in Matplotlib library. So we'll call the alias of Matplotlib library, that is plt dot, then we'll call the function subplots, and inside this function we have to give how many parts you want to, how many rows you want to create the windows in. So we'll create two rows, so for the two plots, then comma, next parameter would be specification of grid like height and width, etc. So we'll use variable called grid specs underscore kw equals to, inside curly braces we'll give our height ratios. So this is a string, and this will have a value in the form of decimal format. So if you want to give for the down part more value or more aspect ratio, you will give 0.85, that is 85% to below plot window, and upper plot window will give 0.15. So this comes down to 100. This you have to put into a parenthesis like a tuple, and both of these values will be saved in these two parameters. So first parameter is f, that is for figure, comma, the second parameter I have contained into a tuple so that they both share the same value. So one is axis for box plot, that is ax underscore box, comma, then the axis for histogram, that is ax underscore hist. So they will have the same value, that's why I have included them into the same parameter. So now what we can do is we'll add these lines to create the two plots. So for that we'll call the Seaborn library alias sns.boxplot function. Inside that will give the data frame column we want to include, that is price, then comma, the axis which you want to include. So we'll give ax equal to ax underscore box. So this will save the computed value ax box into this variable. Same way we'll draw for histogram, that is by using distplot function of Seaborn library. We'll give price as first parameter, and then we'll give ax equal to ax underscore hist. Then we don't need the kernel density estimate, so we'll make it as kd equal to false. So now if you see the plot given below, you can see there are two plots. One is box plot and it is in horizontal format, and we have the histogram that is in without the regression line. Let me show this by running it. So we'll first box fixer and histogram in the same window, and we'll make this as markdown. Now we'll use our code. So first will be figure. So for that we have used f variable, and the second one would be the axis. So I will give axis first parameter is x box, and second parameter would be x underscore dist, and that will be equals to, we'll call plot alias pld dot subplot function, and inside that we'll give two rows we want to create. Then the grid specification underscore kw equals to, open the curly braces, inside that we'll give the height underscore ratios colon, then we can give a tuple. In the tuple we'll give the first one we want 0.15, then second one we want 0.85. so this comes down to 100 or 1. Now if you run this, we'll get two row-wise plots in the same window. So now what we can do, we'll set or both the plots by calling SNS Seaborn library. So first one would be box plot, and we'll give cars data slicing operator, and we'll give price, and then we'll give axis equal to ax underscore box. Run this, it is now taken. Same way we'll go for SNS for histogram. So dist plot, and we'll give cars underscore data, the slicing operator and the price column, then ax underscore hist as our axis value. Then we don't want kernel density estimate, so we'll give it is kd equal to false. And if we run this now, what we can do, we'll include both of them in the same window, and if we run this now, we got both the plots in the same window. So we have box plot here, and we can clearly see the price from 5,000 to 30,000. The 10,000 is the median value, and less than 5,000, that is around 3,500 something, we have minimum value. Then we have around 16,000-17,000 we have maximum value. So same way we can see the count of the histogram, and we can see the count, that is number of cars and the price. So we have around 8,000 rows. We have a lot of cars, more than 150. So this is how you can have more than two plots in the same window. Let's just clear this. Okay, so next I will show you is pairwise plots. So what pairwise plots are used for? They are used for plotting pairwise relationship in a data set. What is pairwise relationship? I will show you that in this couple of minutes. So it will show the relationship between all the different variables in a particular data set, and that would be a pairwise relationship. So it creates a scatter plots for joint relationships and histograms for univariate relationship. So what is joint relationship and what is univariate relationship, I'll show you in a couple of minutes. So this is the code format we have to use. We have to use SNS dot, we have to use a function called pair plot, and inside that we have to give our data frame name. So we have cars underscore data, and then we have to give the kind. So which kind we want to include. Scatter we will give for scatter plot, and then the hue is the parameter on which we want to calculate the pairwise plot. So we'll include fuel type. And now if I show you the output, so this will be output. So let's run and see. We'll call SNS library, then pair plot, then inside that we'll give the data frame, then the kind we want to include is scatter, because if you like scatter plots. Then hue, we want to do this pairwise plot by using fuel type and all the rest of the columns. So if you run this, we got a warning. Okay, we got plot. It took some time, so our plot is drawn. Let me zoom out a little bit. Okay, so one thing I want to show you here is, so I hope you can see here, we have price, then age, then kilometers. These are all the columns, and here also we can see all the columns: price, age, kilometer. So we'll consider price first in the x-axis and the price in the y-axis. So when we have price and price, that is same variable, we get a histogram, that is univariate distribution, because only one, uni means only one, so only one variable is involved, so that is called univariate distribution. For that we are using histogram, and here you can see the KD is also put automatically. And same way you can see age and the age itself. So all the diagonal boxes are histograms because they are actually the column distribution of itself. So that's why it is a univariate distribution of histogram. And the other ones like price versus this one, price versus age, it is, you can see bottom, age it is. So that is scatter plot because it is not univariate, it is joint relationship of two variables, that is price and age. So we can see the negative correlation, and you can see the red, blue and the green color. So those are fuel types. Here you can see the legend. Diesel is blue, actually petrol is orange and CNG is green. So you can see petrol is more here, orange color. Same way we can see the pairwise relationship for all the different variables. So price versus kilometer, then you can see price versus HP. Same way we can see for age versus price, then we can see age versus kilometer, then kilometer versus price, like that. And you can see the positive correlation here, that is between kilometers and age. So as the age increases, the kilometer will also increase. So this is a positive correlation. So you can get more easily the insights or pairwise relationship between all the variables. And some scatter plots don't have any correlation, so that's why they are like this. You can see it's a scatter all over the place. They have no correlation particularly, that's why they are like this, scatter all over the place. So this is how you draw a pairwise plot. So I have used pairwise plot with respect to fuel type. You can also include different variables. So the summary. So we have learned how to create basic plots using Seaborn library. First one we did was scatter plot, and then we did histogram. So for that we had used dist plot function, and for bar plot we had used count plot, and in that we had used grouped bar plots. Then we did box and whisker plot. Inside that we did box plot, then box and whiskers plot, and then grouped box and whiskers plot. Then in the end we did pairwise plots. So guys, thank you for watching. I will see you in the next video.
So in today's video, we will be building a personal income classifier system. So let me show you the problem statement. So in our problem statement, we have a company called Subsidy Inc. that delivers subsidies to individuals based on their income. So accurate income data is one of the hardest piece of data to obtain across the world. This company has obtained a large data set of authenticated data on individual income, demographic parameters, and a few financial parameters. So the company wishes us to develop an income classifier system for individuals. So the main objective of this problem statement is to simplify the data system by reducing the number of variables to be studied without sacrificing too much of accuracy. Such a system would help Subsidy Inc. in planning subsidy outlay, monitoring, and preventing a misuse. Let's look at the variable description of the dataset. So dataset name is income.csv. So you can see the variables. We have age, and the age contains the individual's age in years. Then we have job type. So it contains the category of job types like federal, government, local government, private, and many more. So this provides status of a person, which sector does the person work in. Now we'll go for education type. It gives the level of education a particular person has. So we have 10th, master's, doctorate, and many more. Then we have marital status, in which it will show you the marital status of the individual. Is he divorced or never married or married, and many more. And then we have occupation. In that we have the type of work the individual does. For example, armed forces, in the sales, in technical support department, like that. The next we have relationship. So this variable will contain the relationship of individual to his her household, such as husband, wife, own child, like that. Then we have race. In that it will show you the individual's race, if he is from black origin, white, etc. Then we have gender. In that it will say whether he is a male or female. Then we have capital gain. So capital gain of individual, it is from selling an asset such as stock or bond for more than the original purchase price. So it is called as capital gain. The capital loss is the converse of capital gain, such as it gives the capital losses of individual from selling an asset such as a stock or a bond for less than the original purchase price. The next one is hours per week. So the number of hours per week the individual works will be given in the hours per week. The next variable we have native country. So it will give the native country of the individual, such as United States, Cambodia, Canada, and 39 more. Next one is salary status. So this variable will indicate whether the person's salary status is less than or equal to 50,000 or it is greater than 50,000. So these are two categories of the salary status. So let's look at how to import this data frame and do the analysis of all the data inside it. So here you can see that we imported our libraries. So we'll need pandas, and we'll need numpy, and we'll need seaborn for visualization. So the next thing is we'll partition the data. So for that we'll make use of a package called scikit-learn. So just import sklearn dot model selection. So this is a sub package of sklearn library. And then from that import train test split, and just run this. Now we'll import the library for logistic regression. So the same thing from sklearn library, from the sub package linear model. We'll import the logistic regression, and now we'll import some performance metrics from sklearn. Those are accuracy score and confusion metrics. So for that, just type from sklearn dot metrics import accuracy score and then confusion metrics. Just run that, and now we'll see our data set. So we have imported our OS. So we'll type os dot list dir, and we didn't run this one, so now it is imported. Now we can run this one and we can see our CSV file, that is income.csv, is present here. So now what we can do, we'll just import it. So for that we'll use pandas. So we'll make a data frame called data underscore income equals to, we'll do pd.read CSV function, and in that function we'll give the name of our CSV file. And now what we can do, we'll copy this data frame into another data frame, so that whatever changes we do, it is not affecting our original data frame. So the name of our data frame is df equal to the original data frame, that is data underscore income, then copy function. And what we can do now is we can check the variable data types. So for that we'll just call df.info function. So this will give you the variables description. So you can see age is integer, job type, education type, all these are of type object, means it has categorical variables, all this. And apart from that, capital gain, capital loss, hours per week are in integer format. So we found this one, and we can see that we have 31,978 entries that are rows, and we have 13 columns. Now what we can do, we'll find out if any missing values are there. So there is one function for that called isNull. But what this will do, this will give us in true and false. So if true is there in any column, in particular row, it is missing value is present there, and if it is false, then it is not. But it is not a good way. So we can use some method on top of isNull, so that we can get in a summarized way all the columns which has missing values. So we can see that none of the columns have missing values, so that's good. So this was for finding the missing values. So we have done that. We'll just take this up, yeah, and we don't need this, we can just cut that. So now what we can do, we'll find the summary for numerical variables. So for that we'll take one variable sumNum, and inside that we'll pass df.describe method. So whatever output is there, it is present in sumNum, and you can see it is giving us 8 different categories for these numerical variables. So we have age, capital gain, capital loss, and hours per week. You can see there are count is the number of rows present for each column. So it is 31,978. Mean is the average. So 38 or 39, you can say, years is the average age of a particular individual. Then the standard deviation is 13.66. Then minimum age is 17 years. 25% of all the age of people is 28 years. 50% is 37. 75% is 48 years, and maximum is 90 years. Same way, capital gain, you can see the average capital gain is of 1064, and the standard deviation is 7298, and you can see maximum capital gain is around 99,999, and there is no 25%, 50%, 75%, because the average capital gain is 1064, which is way beyond 25%, way below 25%. So all these are 0. So same way for capital loss also, all these are 0, and the maximum is 4,356, and standard deviation is 401, and mean, that is average, is 86. So hours per week is 40 hours an average, and standard deviation is 12. Minimum hours per week is 1 hour. 25% is 40 hours. 50% it is half, it is 40 hours. 75% is 45 hours, and maximum is 99 hours per week. So now let's look at summary of categorical variables. So how we'll find summary of categorical variables? So for that we'll make a one variable sumCat, and inside that we'll pass df.describe. the same function which we used for numerical variables, but we'll pass one parameter called include equals to, inside that we'll pass capital O. So this will take into account categorical variables and it will give a description of all those variables. So we'll pass sumcat here. If we run this, we'll got all these categorical variables: job type, education type, marital status, occupation, relationship, race, gender, native country, and salary status. So it is giving the count of each one of those categorical variables, and unique is the number of columns present, number of unique categories present in a particular column. Job type has 9, education type has 16 unique categories. So top means the model category of this particular column. Model category in the sense whose frequency is more than any other category in that particular column. So the frequency of private job type is 22,286, which is maximum out of all those particular categories in the job type column. Same way for HS grade is the highest category in education type, which has frequency 10,368. So you can see we can get this description about the categorical variables using this describe method. So now we'll go for frequency of each category. So how we can find the frequency of each category? So for that we'll use data frame df, and inside that pass the particular column which we want to take into account. So we'll take job type and then we'll just call value counts function. So what this will do, this will give frequency of all the particular categories present in a particular job type column. So we have private 22,286, self-employed not included, local government, but we have one more, that is question mark. So question mark is unwanted value. It doesn't depict anything, so it should be converted into none value. So let's see in any other column we have or not. So none other column will have apart from occupation. So just see if occupation has something like this. It has also a question mark. So now we'll check these unique classes, because these classes might have some different behavior when they are produced using this data frame value counts. So we'll use numpy for that. So we'll call np, that is numpy, np dot unique function. So this function will pass our data frame and the particular column which you want to target. So we have job type, and if we run this, the categories in the particular column have space before them. So you can see question mark has a space, that is white space. Federal government also has white space. So all the categories has a white space before that. Same way we'll check for the occupation. Here also we can see there is a white space prefixed to the category. So now we'll replace these question mark with the none values. So for that what we can do, we'll create a new data frame, or we can just change the data frame in the top, but I prefer to make a new data frame, and we'll just import CSV file again. We'll include a na underscore values, and this parameter will take our question mark. So we should have white space and then question mark. And now if you run, we have imported the data into data frame called data. So now we can do data pre-processing. So for that we'll call our newly created data frame data, then we'll just call isNull function to see how many missing values are there. And now you can see there are 1809 missing values for job type, and for occupation we have 1816 missing values. We have changed the question mark into the none values, so that's why it is showing like this. But why it is showing the difference from 1816 to 1809? So let's find out. So what we can do, we'll create one variable called missing, which will contain all the missing values. So we'll call our data frame data. Inside that we'll pass data dot is null, and then we'll select axis. So we'll select axis as inside the any function we'll give axis equal to 1. So this means that we want to take into account at least one column whose value is missing. So now if we run this and if we see the missing values from the missing data variable, we'll just take 10 for beginning. So we can call missing dot head. Inside that we'll give 10. So we can see the job type is none and occupation is also none for the data frame. Now what we can do, we'll sort the data frame missing. So we'll use sort underscore values, and inside that we'll give the particular column which we want to sort. So we want to sort the job type, and if we run this we can see our job type is sorted. So in here we have never worked, so the occupation is none. Since the job type is never worked, the occupation is automatically is empty. So here you can see this never worked category has none values for occupation, and other job types are none, same for occupation also. So now we found out where the difference has come. So missing values in job type is 1809, whereas missing values in occupation is 1816. So if we minus that, we get 7 rows which has job types never worked. So due to that, the occupation is unfilled for these 7 rows. In earlier videos I have shown you how to fill these missing values, but in this particular scenario this system is very much complex. Since we don't know the relationship between job type and occupation for other columns, we can't fill these categories. So what we can do is we'll just drop these categories or particular rows. So for that what we can do, we'll create a new data frame, data2. So we'll pass data dot drop na. This function is used for dropping the values. We'll drop the rows, so we'll give access equal to 0. If we run, now let's see how many values we have dropped. So original one was data, so we'll run data.info. You can see it was 31,978 earlier. So after dropping the rows, we can see data2.info, it's 30,162. So around 1,000 something rows are dropped. So now we'll get the relationship between the independent variables. We'll create a correlation variable. Inside that we'll pass our newly formed data2 dot core function, and if we run this correlation, you can see that the correlation is between these numerical variables, age, capital gain, capital loss, and hours per week. Nowhere it is near 1. Since the correlation goes from -1 to 1, so -1 is negative correlation and near to 1 is positive correlation, and if it is near to 0 there is no correlation. So here you can see none of the variables show values close to 1, so these are not correlated to each other. In the next video we'll look at the further steps in the data preprocessing for this particular case study of classifying the personal income. And in the last video we had seen the correlation between independent variables and dropping the missing values. So in today's video we'll see the cross tabulation and data visualization. So let's get started. So what we'll do first, let me get an idea of how many columns are there in particular data frame. So data frame we had was data2. We want to see the columns, so data2 dot columns will give us all the columns present in the data frame. Here you can see age, job type, salary status. So let's see the gender proportion. So how you can see the gender proportion? So for that we'll need a gender from the data frame, and we'll use pandas cross tab function. So we'll create a variable called gender equals to pd dot cross tab. So in this function, we'll pass first parameter as index equals to the data frame column which you want to consider. So we'll call data2, then slicing operator, and then the gender, that is the column. The next thing which we want is columns. So columns we'll consider as count, because we need a count of the gender. And then we want proportion, so for that we'll use normalize equals to true. And if you now print the gender variable, we can see the proportions of female and male in the population. So here you can see male proportion is more, that is 67%, whereas female is 32%. So now let's see bivariate analysis. So we'll consider two variables, gender and salary status, and we'll find out what is the relationship between them. So for that, what we can do, we'll just create a variable same like gender. So we'll consider gender underscore salary stat equals to, we'll call cross-tab function again, and inside that we'll pass index equals to which column we want to consider from data frame. We want gender, and next one is in the columns we'll consider the salary status, that is a column. So SAL ST AT comma, along with the gender male and female category, we want all categories, so we'll consider margins equals to true to get that. And the next one is normalize, so to convert the count into proportions. And if you run it, and if you just print this, we can see all along with that female, male for salary status of greater than 50,000 and less than or equal to 50,000 for two categories. We can see that male has 30% population who has category of greater than 50,000 salary, and female is only 10% for greater than 50,000 rupees salary. And in the less than or equal to 50,000 category, we can see the females has 89%, whereas gents has 69%. So overall, male has more as compared to females. So let's see the frequency distribution of salary status. So for that, what we can do is we can draw plot using Seaborn library. So we'll create a variable called salstat equals to, then we'll call SNS, that is Seaborn library, and from that we'll call countplot function. So in this, if you give the salary status column of data frame is data2, and the column name is salary stat. If you run this, we get a count plot, and here you can see 75%, that is this is less than or equal to 50,000 rupees salary people, whereas 25% is greater than 50,000 salary people. So now we'll see frequency distribution of age. So how we can see that is, we'll just call the Seaborn library again to plot a dish plot. So dish plot will show us the distribution of age over the intervals. So the column which you want to consider is age, and then how many number of bins we want. So we'll consider 10 bins, that is 10 intervals or columns you can say, and the kernel density estimate, that is KD, we don't want, so we'll equal to false. So the frequency will come to the y-axis if we make it KD equal to false. If we now run it, we can see that the age is given from 0 to 90 and the count is given here, and in here you can see people of age 20 to 45 are in very high frequency, whereas other age people are not that much. Now we'll do bivariate analysis for age and sales stat, that is salary status. So how we can do is, we'll use box plot this time. So SNS dot box plot, and what we'll plot is we'll use salary state. Along with that, we want age also, so we'll compare both of them, and data will get it from the data frame data2. And we also want to group by this data frame, so we'll use group by function. So data2 dot group by, so inside this function will give us our variable, that is salary state. So the data frame will be grouped on the basis of the salary status, and in that we'll use age as slicing operator, and we'll consider the median of that age. So salary status will be grouped by on the basis of age of median. And if we now run this, so we have a spelling mistake, so it should be grouped by, and here we can see the salary status. So people with 35 to 50 age, you can see 35 to 50 age are more likely to earn greater than 50,000, whereas people from 25, that is this much, to 35 are more likely to earn less than or equal to 50,000. So this was bivariate analysis for age versus salary status. So I want you to practice for bivariate analysis for job type. So job type is a column, job type versus salary status, and also for education. So compare these columns and find out insights from them. So education versus salary status, and then also occupation versus salary status, also for hours per week versus salary status, and also there is one variable called capital gain. So try to get bivariate analysis on that also. So this will help you in practicing and getting more understanding of bivariate analysis. So in the same way, like I have done box plot, count plot, dist plot, we can do bivariate analysis for all these columns. So guys, thank you for watching, and I will see you in the next video with a different case study. And in the last video we had seen the bivariate analysis and EDA on our data frame. So in today's video we'll learn about logistic regression model, how to build it, and what is the use of it. So logistic regression model is a machine learning algorithm which is very helpful for categorical variables. So right now we have so many categorical variables, job type, education, etc. So we need to convert those into numerical variables. In the sense, we want to make it into integer form. So how to do that, I will show you. And one more thing, machine learning algorithms takes input as integers, so we need to convert them from strings to integers. First we'll reindex the salary status names to 0, 1. Right now our data frame was data 2. So if you go and see the salary status variable from data 2, if you just print it, so yes should be capital. You can see all the string values here, less than or equal to greater than 50,000. So what we will do, we'll just use the data 2 and we'll select the salary status variable, re-index the salary status names to zeros and 1. So salary status we'll get from here. What we'll use a map function, and inside that we'll pass the names or the category names that is less than or equal to. So we can just print it first. So we'll take this one and we'll just paste it here. Keep in mind that there is a white space prefixed, so this will be the 0th one, and next is greater than 50,000. It is also having a white space, and just paste it here, and this will be corresponding to 1. So wherever the value is less than or equal to 50,000, the string, it will convert it into integer 0, and wherever it is greater than 50,000, it will convert it into 1. So this is called as integer encoding. So this is just a warning, and what this integer encoding helps us to, it inverts the labels from the integers afterwards whenever we require. So it will be helpful afterwards. So let's just check the salary stat column if the values are changed from string to integer. So here you can see they are changed. The next thing you want to do is we'll create a new data frame called new data. Inside that we'll use pandas getDummies function to convert all the categorical data columns into numerical data. So how we can do that, let me show you. So in the pandas course I have already shown you how to use the getDummies function. So this function will take the data frame, so as first parameter, that is data 2, and we'll also drop first equals to true. So we pass this parameter, and whenever we run this, it will convert. So there are 3. Okay, so it will convert all the categorical data into separate columns, dummy columns. So let me show you. If you just use new data.head, you can see. So job tabs, there were 7 categories in one row. It is converted into 7 columns now, as job tab local government, job tab private, job tab self employee, all this. Same way for all the categories, it has created dummy variables, and you can see in this row wherever there is 1 in particular column, so that is the job tab of that particular person. So job tab private is having 1, so it is the job tab of that person, and rest is 0, so it is not. So next what we have to do is we have mapped all the integers, all the strings to integer to work with the ML algorithm. So now we'll divide the columns to independent and dependent variables. So we have to find out which is dependent and which is independent. So salary status is independent according to me, and all those other columns are dependent on salary status. So dependent variables will be going in Y and independent will be going in X. So let's just store the column names for our reference. So we'll create a list and we'll give the list name as columns list equals to, we'll call list constructor. Inside that we'll pass our new data frame, and we'll just call the columns, and we can just print it if you want. It will give you all the columns that are present in the columns list. Now we'll separate the input names from the data. So this will be the features which include all the dependent variables. So how we can get that? So I have already shown you independent we have y. So we'll have one features column, features variables. Inside this we'll pass our list constructor, and it will having a set, and it will take our columns list. So we want to separate the salary status from rest of the columns. So we can do columns list minus set the data frame, that is new data, and the variable name or the column name salary status. And if you run this, you'll get the features, and you can just print the features, and it will give you all the columns names apart from the salary status. So these are all features or the dependent variables. And now what we can do, we'll store the output values in y, that is independent. So what is independent? That is salary status. So we'll store it in a variable y. So y equals to new data, and we'll use slicing operator. Inside that we'll pass salary status. So keep in mind that we have not stored the values, so we'll just store the values inside the y. And if you print y, we'll use zeros and ones because salary status contains all zeros and ones. Next thing we'll do is storing the values from input features. We also need to store the values for dependent variables. So for that we'll use x variable, x equal to, we'll call the new data frame, and we have our features column, and this features column will have values. So we'll just grab those values in the x variable. We will just print the x. You can see we got all the values here, all the integer values. Now we'll just split the data into train, test, split. So as soon as we got our independent variable y and the dependent variable x with the features, you can just split the data. So for that we have already imported the function on top. We'll just now use 4 variables to store the data coming out. So one is train x, one is train, first is train x, then we have test x, then we have train y, test y. And what we can do, we'll just call our train test split function from scikit-learn that we have imported earlier, and we'll just first will be our parameter will be our input x, and our output will be y, that is second parameter. Then next will be parameter called test size. So test size will be 0.3, that is 30% of all the population we are considering for test. And next thing is random state. So random state is the seed for random state generator, which will help us to sample out random data from the data frame. Right now we'll just use it same. So for that we'll use random state equal to 0, so it will not change the sampling. And if you run it, it will give you the 4 variables. You can just print them if you want, and it will have values. Now we'll just make an instance of the model. So we'll use one variable logistic, and we'll save a model for that. So we'll call the logistic regression function, and our model instance is created as logistic. So we have to fit it now So I will show you that in the next video. And in the last video we had seen how to split the data into test and split. Then we had made an instance of the model. But in the last video we had made one mistake, so I want to show you, which is what. So here, in separating the input names from data, that is creating independent dependent variables. So we had created one features variable. So inside this we had given the column list and new data. So we don't need this new data frame. We can directly give cell state, and if we run it, there will be no such mistake. We'll run all those instructions again, and we'll split data into train test split, that is train x, test y, and train y and test y. So we will create one instance of the model. So I'd shown you in the last video, that is logistic. We'll create one variable logistic, then we'll call our logistic regression method, and this will create an instance of the model. Now we'll have to feed the values for x and y, so independent and dependent variables. So how we can do that? So we'll call our this one model instance logistic, then we'll call fit function on top of that, and we'll pass train x comma train y. And if we run it, it will fit the model on both the training data set. We can verify the coefficient of that. We can do logistic, then there is one variable called coefficient, and we can call that with coef and underscore, and it will give you array of all the coefficient of the train and test x. Same way we can also call the intercept. So we just need to call the object logistic, then we can call the intercept underscore will give us the value of intercept, that is -3. So next we will see the predictions from test data. So we'll create one variable called prediction, that is equate to logistic dot, we'll call the predict function. So inside this we have to pass our test data, so with the data which we have not used till now, so it is test x. So if we run it, and if we just print it, it will give all the integers, zeros and ones, the list of integers. Next you can see the confusion matrix. So confusion matrix is a table which shows all the number of correctly and incorrectly classified items in class-wise form. And let's see how to do the confusion matrix. So we'll have to call confusion matrix function. Before that we'll create one variable confusion matrix, that is equated to, we'll call our function confusion matrix, and inside this we'll pass our test y, that is second test data frame, and we'll give the prediction, and we'll just print the confusion matrix output. And if we run this, we can see it gives us a matrix, and in this you can see the diagonal elements. So these elements are correctly classified classes, and these off diagonal elements are incorrectly classified classes. And one more thing is that the rows will give you actual classes, and the columns will give you predicted classes. So for example, we had seen our salary status classes. Inside that we had two categories, less than 50,000. So if a actual class is less than 50,000, So in that 6332 classes are correctly classified, whereas 491 classes are incorrectly classified. Same way, if you think about the greater than 50,000 salary status, in that 1290 is correctly classified, whereas 936 are incorrectly classified. So as I already said, diagonal elements are correctly classified classes, and off diagonal elements are incorrectly classified classes. And we have two sets, that's why we have given it like this. One is for less than 50,000, one is for greater than 50,000. Now let's calculate the accuracy of the model. So this is our classification model. So we'll create a variable called accuracy score that is equated to, we'll call our function called accuracy score. Inside that, we'll give our test data frame, that is test y, and we'll give the prediction a second parameter, and we'll just print the accuracy score. And if we run this, it will give us 0.84. So which means that 84% of the data in the data frame is correctly classified by the model. So let's see how many are misclassified values are there from the prediction. So for that we can use just print statement, and inside print statement we can give as misclassified samples, and we can display it in the form of %d, that is for digit, and we can get that using the % symbol, that is for modulus, whatever it is remaining, and we'll just open it. Okay, inside this we can give our test y data frame, which is not equals to the prediction. So whatever is misclassified will be present, and will not be equal to prediction. And what we can do, we'll take this up and we'll get all those values, and we'll make sum of that. We'll get all the count of those values and we'll sum it, and if we run it, we'll get misclassified samples as 1427. So these many classes are misclassified by our model. So in the next video, I will show you how to improve the accuracy of the model by removing the not required values. Thank you for watching, and I will see you in the next video. In today's video, I will be showing you how to remove the insignificant variables from the features list and rerun the model. So here you can see in the last video we had shown you the separating of input names from data, and we have included all the features except the salary status. So in today's video, what we will do, we will remove the insignificant variables such as gender, native country, all those. So what we will do, we will just get this data 2 and salary status. Let's go up. Yeah, so we had re-indexed the salary status names to 0s and 1. We'll just copy this. So what we will do, we'll just copy and paste it here, the data to salary status, and in here we are just mapping out the strings, the values 0s and 1. So less than or equal to 50,000 will be 0, and greater than 50,000 will be 1, and we will save that in the salary status variable of data frame 2, and we'll run this. We got a warning, but it's okay. Now what we'll do, we'll select the insignificant variables. So we'll just create a list called columns, and inside that we'll give the insignificant variables. So gender is there, then native country is also there. And race is there. Along with that, we also have job type, and we run it. Now what we'll do, we'll just get our new data frame, and inside that we'll call data2 data frame, and we'll just we'll call the drop function, and we'll just drop the columns. So we'll pass the columns list, and axis we will select as 1, so it will delete the columns. So now the columns are dropped. We can just check it once if you want. So here you can see age, education type, marital status, and occupation is there. So next thing what we will do is we'll just call the new data frame, and we'll just call pandas and get dummies function just to convert the string columns into numerical columns. So we'll pass the new data frame inside this. This is not a string, so we'll remove this, and along with that we'll pass drop first parameter, so it will not create duplicates. And we'll run this. And now in the last video we had shown you same way we have to do, that is the column list, then creating features. So if you go up, I don't need to copy it again, so I'm showing it from here only. So this was the column list, so we'll just run it and we'll just print it. So here you can see it is less than earlier because we have removed some insignificant variables. Now just we'll run separating input names from data. So we'll just run these features, and we'll print features also. So you can see features are reduced, and storing output values in y, we'll run this also. So now you can see the y, that is independent variable of salary status, and now dependent variable, that is all the features without considering the insignificant variables. Now we'll just split it into train, test, and we'll just create an instance of the model called logistic, and we'll just feed the values for x and y. So train x is input and train y is output, and we don't need to check the coefficient. Just go down, and we'll just check for prediction. And we can also check for confusion matrix, and less than 50,000, if class is there, then 6317 is correctly classified and 506 are incorrectly. Same way, if it is greater than 50,000, 1274 are correctly classified and 952 are incorrectly classified. And accuracy will check. So 84 was earlier accuracy, and if you run this, we can see it is 83. So after removing the insignificant variables, the accuracy is not increased, but it is decreased. And we just check the misclassified values from prediction. So 1427 was earlier, now it is 1458. So accuracy is reduced due to that. The misclassification is also increased. So it's better to include all the features for particular data set like this. So let's move on to next one, that is KNN classifier model. I'll just delete these cells. So what KNN classifier does is it will have k nearest neighbors. So according to the neighbors, the number of neighbors, it will create the classes, and it will create clusters like depending on the most occurring classes. So what we'll do, we'll just import the k nearest neighbor from sklearn. So from sklearn dot neighbors, we have to import k neighbors classifier, and also we want to import the matplotlib pyplot function or module as plt, and we'll just now store the nearest neighbor classifier. So for that, we'll just create one variable kn underscore classifier equals to, we'll call the k neighbors classifier function or method. Inside that, we'll pass the parameter as neighbors, so n neighbors. So now we have to give the neighbors which how much we want to create. So we'll create 5 neighbors and we'll run this, and next would be fitting the values for x and y, that is input and output. So we'll just call our model instance, that is kn classifier, then we'll call the fit function, and inside fit we'll give input as train x and output we want train y. So these are the data frames. Run this, and the next will be predicting the test values with the model. So we'll create one variable called prediction equals to, we'll call the model instance kn classifier, and we'll call the method on the top of that predict, and we'll just pass the test data frame. So we have test x, just run it, and we'll also check the prediction. It will give ones and zeros, you can see. Now we'll just check the performance metrics. So performance metric in the sense confusion metrics. Confusion, we can just copy it from top because we have already run this. So here you can see confusion metrics, just copy it to save time for ourselves. If we run it, we got an error because the confusion matrix for test y and prediction is already done for k, for this one logistic regression in significant variables. So what we can do, I will just go on top and just start from the beginning. So beginning in the sense data frame we had created. So I will just run this one. So we'll go on cell and cell run all above. So it will run all the this one. So you can see 102 it is. So the data 2 is run again and all the above commands. So we'll just go down for the KNN classifier. Okay, so we'll just import it again, and we have to get the train x and train y. So that also we'll get it from this one. So we'll just run this. So I'm taking all the features for this one. We don't need to print it. We'll run this till we get our train test and split. So we got. Now we'll not go for creating the instance. We'll just go down for the KNN classifier, and we'll just create an instance of KNN classifier, then fit the values for train x and train y. Now prediction. So prediction will be done. We'll wait for some time, and now we'll go for performance matrix, and it should not show error. So we can see the confusion matrix. So out of 600 and 181 actual classes, that is less than 50,000, it has correctly classified, and 642 are incorrectly classified as greater than 50,000. Same way 1412 are correctly classified as greater than 50,000 and 614 are incorrectly classified. 814 are incorrectly classified as greater than 50,000. Now just we'll calculate the accuracy. So accuracy also we can copy it from top on top. Here you can see, or we can just run it there only. So accuracy will be pasting here, and you can see it is 83.9. It is around 84%. So the accuracy is also less for this one as compared to the logistic regression with all the features without removing the insignificant variables. And now just check insignificant misclassified samples. If you go on top, we had seen 145 misclassified samples. Now we'll run this and we can see 1456, that is 2 less than 1458. So this is how you create a k nearest neighbor classifier model, and you can see also the accuracy. And in the next video I will show you how to check for different number of neighbors for k nearest classifier. Right now I have given 5, so we'll write a method for that and we'll just go around and check how many number of neighbors gives us better classification and correct classification. So thank you guys for watching. I will see you in the next video. In the last video I had shown you the KNN model and how to build it, and we had also checked the accuracy, and we got it around 83%, which was less than the logistic model. You can see we had misclassified samples as 1455. Now today I will show you the effect of k value on the classifier. What we will do, we'll create a list, empty list called misclassified sample, that is equal to empty list. And next thing would be, we'll calculate the error for k values between 1 and 20. So we'll get best among them. So we had tried for only 5 last time. As you can see here, n neighbors we had given 5. So we'll now give 1 to 20 and we'll select the best one which has better accuracy and less number of misclassified samples. So let's do that. So we'll call our for loop. So for I in range, we'll give from 1 to 20. What we want to do, we'll create one instance of the KNN classifier. So KNN equals to k neighbors classifier. Inside that we'll give neighbors and we'll give the value as I, and then we'll just fit the model, that is input and output, on the model instance. So input would be train X, and output would be train Y. So these are the data frames. Next thing would be, we'll create one variable called prediction I. So it will iterate over the loop and it will save all the predictions. So we'll just pass the prediction to that. So knn.predict function. Inside this we'll pass our test frame, that is test X, and then we'll just call our list, that is misclassified. We didn't run it, so we'll just run it. Okay. Now you can just use tab, and now you can see misclassified sample dot append, and inside this we'll just pass our test by is not equals to the prediction of I. Then we'll just sum the values and just run this. It will take some time because it is calculating for each case from 1 to 20 for all the neighbors. So we'll start from neighbor 1 and it will go till neighbor 20. So we'll wait for some time. Until that, we can type misclassified sample. Okay, it has run, so we'll just print the list and we can see the values. So we'll find out which one has the lowest. So we have two values, 1405 and which comes around, so 14 and 16 are the neighbors which will give us the best values. If you want, we can try it out. We'll just put it here as 14 and we'll just run it. Then we'll just fit it. Then we'll just predict it. Test x. And we'll just run the confusion matrix. It will give error because, as you can see in the last video, it's shown you. So to test x and test y, we have to run it again. So if you go up, you can see the test train split method on top. So this we have to run it again. And just to cell, run all above. That should do the job, and we'll go down to our k neighbors. And then we'll run this. Now we should not get error for confusion matrix. You can see it has classified 6398 correctly and 1246 correctly. This is for less than 50,000, this is for greater than 50,000. And just calculate the accuracy, and it is increased to 84%. As you can see, finding out the right neighbors number. So it was 14 this time, we get higher accuracy. You can just check the misclassified samples. It is 1455 for the neighbors S5. Now check for 14. So you can see it is reduced to 1405, that is 50 samples are classified correctly. So this will help you in classifying or improving the accuracy of your model.